we're going to do another example of constitutional isomers. And this time, we're going to be doing isomers sharing the formula C3H9N. So we have one nitrogen. So again, let's start doing combinations of that. So 3 carbons, 1, 2, and 3. And I'm going to draw a nitrogen here. And I'm going to start filling valences. And right now, I have these 3 carbons on a row, and I have my hydrogens. So that's one compound. Right here, because we need to learn functional group, this is an amine. And in fact, it's a primary amine. And now let's do another combination yet with the same formula. So I'm going to go, now we said we had 3, 1, 2, and then I'm going to put the nitrogen here and put another carbon here. Remember that common pattern, bonding patterns for carbon is having 4 bonds. And they can be 4 single bonds or 1 double, for example, and 2 singles, and so forth. A typical pattern for nitrogen would be, for example, in the case of ammonia, we have 3 bonds and 1 lone pair. This is for nitrogen with 0 formal charge. So that is a pattern. We're going to do that pattern here. So I'm just in this picture, one of these 3 hydrogens was replaced by all this chain. Now I am replacing 2 of the hydrogens by 2 carbon chains. And I'm going to just complete the bonds. And because nitrogen still needs 3 bonds, 1, 2, 3, in 1 lone pair. And now notice that this compound is different. We have the nitrogen in the center, and that is another functional group. It is an amine, but this time we have this. But in this case, we have replaced 2 of the hydrogens by this alkyl chains. So that is a secondary amine. And clearly, atoms are connected in a different way. Now I'm going to do another combination here. Next, I'm going to do, let's say that I want to replace the 3 hydrogens. And I'm going to draw my carbons here. And remember, nitrogen, if it's 0 formal charge, we have 3 bonds and 1 lone pair. So here it is. And what I need to do next is just complete the 4 valences for carbon. H. And here I have C3H9N. Now this time the nitrogen is here and it will have 3 carbon chains. Now I have replaced the 3 hydrogen by that. That is another amine, but this time, because we have 3 groups, it's called a tertiary amine. So this is because, again, we need to learn functional groups. So here in this example, I am illustrating how you can create different constitutional isomers, that is, different conformers, different compounds that share the same molecular formula, but they have different connectivity. And also we have learned here that we have this functional group amines, and that we can have, if we replace only 1 hydrogen by a carbon chain, we will have a primary amine. If we replace 2, we will have a secondary. If we replace the 3, we will have a tertiary. So that is summarizing what we learned here. Constitutional isomers, and we have learned about that functional group. We'll do more in another video.